Okay. Okay, so first of all, let's look at your results from your pore plating. Let's go over some pore plating results. And I better say it's not that good. Okay, first of all, you could see you 10 to the 3, this will be obviously is TNTC. You can see it, obviously. And it's a big mess. You can't even see really clearly what it is. And 10 to the 5th, it is also horrible looks. But some of you, let's say that 10 to the 7th, let me have it. Can I have that one? That looks pretty okay. This is actually pretty good. To be honest, this is 10 to the 5, is that right? That looks okay, looks. But you see those big chunks, those smaller ones, ideally you have to count everything. You know what I'm saying? You have to count everything. But this looks okay, it looks like a pore plating. So we're going to look at the 10 to the 7th, what it looks like. Well, 10 to the 7th, this one looks fine too. You see a big chunk, you see some smaller one, so that will be 10 to the 7th. 10 to the 7th, absolutely you can count. So I want 3 number the whole classroom. Can you count that? Count everything. Yeah, just give me 3 numbers the whole classroom. I want a 10 to the 7, just tell me. If your place is horrible, you don't have to do it. If it looks good, accountable, you can do it. Okay, that's very interesting experiences. Is that meddling? Yeah. Please go ahead to count instead of laughing, okay? Very important. 37? 37, that's good. So we have first number 37. 30, second number?
34.
Oh, it's 34, that looks good. Who else have another number? I don't want another number. 53, good. So, what you find? If you compare to what we talked about before, this is all legal zone. Is that right? 30 to 300. So that's all usable. And then we can check the average. 71, 124, divided by 3, it is 40, that was 41, 41.3. Okay, we'll just say 41. So it is 41, and multiple by 10 to the 7. So that equals 4.1 multiplied by 10 to the 8 CFU per ml. And if we transfer to the log, it's basically 8.4 log 10 CFU per ml. And you can compare your spread plating, it's a little bit lower, about like 0.2, 0.3 log lower because of the mild heat. Okay, so slightly lower than spread plating. Okay, so around maybe 0.3 to 0.4 log 10 CFU per ml less. About, okay? So obviously you can see which one you like. You definitely like spread plating. It is much easier and much clearer, you get the quality. And this one is kind of confusing you sometimes. Now, why people do this? There's 2 reasons. Number 1, some people are just lazy, don't want to mix agar on a separate day. They just want to mix up everything. Makes their life easy. Second day is that usually this pore plating is for the number, is for a range. So for example, if I have a bunch of meat, let's say, okay, I want this meat to test it. Their number is less than 10 to the 5, for example, and I pass some of the standards. Then I can put the meat in a bag to filter, then we do pore plating. I don't need to know exact number. As long as I know the number is less than 10 to the 5, which is good. That's the reason sometimes we can do pore plating. But spread plating, we need to know exactly the number. So that type of the thing I could think about is people want to use pore plating to do. It did save you a day to make a media. However, you can compare the results, not that good. And it's even confusing you. And it's hard to count because it's everywhere. Okay? So that's what we talk about the pore plating. Today's lab, I will say, is important. You have a fact sheets right here. And I will talk about our second page. It's a quiz for you. Two of you work together. We will talk about is bacterial media. So this will be lab 9. We talk about the bacterial media. And remember, bacterial media based on physical status, we could separate them into solid, liquid, and semi-solid. This is the content we talk about in the lecture. Now today, we all going to do is agar media on the plates. So obviously, these are solid media. That's the first thing first. Okay, based on the function, they will separate them into support media, enriched media, selective media, and differentiated media. And this is we will talk about today. It will be a key. And the first time you really go ahead to recognize the media. So let's talk about these one by one. You will get first is a neutron agar. You did all 3 labs already. This is a support media. So first thing first, the neutron agar. Neutron agar obviously is a support media. This is basically, we had a salt, we had a beef extract, and then we have a beef extract. We have a peptone, a traptone, and then don't forget we had agar. This agar usually is 15 grams per 1 liter media. Okay, so it's solidified. What is the support media for? Vegetative cells can grow around 10 to the 8 cells per ml. But it is a so-called solid media. So we'll take this concentration out. Okay, just to let you know, the vegetative cells will grow, except fastidious bacteria. Let's say we talk about the Haemophilus influenza, Neisseria, meningitis, gonorrhea, those will not grow. So that's the first one, neutron agar. We all talk about this already. Second one, McConkey agar. McConkey agar looks like purple. So the first question, why it looks like purple? Because there is a major ingredient there, crystal violet. Same the dye you use for the gram stem of the first step, crystal violet. Same thing. Okay, because crystal violet will attacking gram-positive bacteria, peptido glycan. Therefore, gram-positive bacteria will not grow. Only gram-negative bacteria survive, I will say. So, Macanchi agar is a selective media. This is a selective media because can differentiate the gram-positive and the gram-negative bacteria. That's the first thing. The major ingredients, crystal violet, that's why it is purple. Second, I talked about it in the lecture already. These type of Macanchi agar, there is another major ingredient there is lactose. And the lactose is a disaccharides, okay? Lactose could differentiate lactose fermentation positive and the lactose fermentation negative. If the bacteria cause lactose fermentation positive, it is actually a pink. Color. If it is negative, then we just say colorless. Now, why it is a pink color? Because inside of here, they have a pH indicator, which is called neutral red. The neutral red at lower pH will turn pink. So if it's lactose fermentation positive, it's pink. Lactose fermentation negative is colorless. Now another thing, in your textbook it mentioned that they also have bile salts there. So it will cause precipitation, and then you generate a so-called a halo. But this is difficult to see, hard to see sometimes. Okay, we want to emphasize that here. Next one. Remember you exam 1 lecture. We have a little bit of difficult question. Mannitol salt agar right here. So that's a second agar. Mannitol salt agar. Okay, first of all, why it is a little red? Because it has a component called the mannitol. And the mannitol is a modified sugar. The same as the Macanchi agar, based on the fermentation results, it could separate mannitol fermentation positive and the mannitol fermentation negative. If it is mannitol fermentation positive, it is yellow colony. Otherwise, it is colorless. Now, why it is a yellow colony? Because the pH indicator is phenol red. And this phenol red at low pH is yellow. We will mention this phenol red again when we go to the biochemistry test. Okay, so that's a mannitol. Second component is salt. And we mentioned about, we could separate the bacteria as halophiles and non-halophiles. And this salt somehow is about 0.6% salt. Sometimes it's about 0.6 to like 6% or like 3%. It depends, different combination. So halophiles will grow, non-halophiles will not grow. So this tells you both Macanchi agar and the mannitol salt agar, they are both selective and differentiate media. Okay, last one. Blood agar. Blood agar very red. Like this. Looks like blood. Okay, what is blood agar? This is contain 5% sheep blood with neutral agar base. Now, why we use sheep blood? We mentioned about before, because in 1970s, people find the sheep blood, the characteristics is same as human blood. So they use sheep blood. It is an enrichment media. Enrichment media can let the bacteria grow almost to 10 to the 9 cells per ml. It is more important, it's a differentiated media. Why? You still remember we talked about in the lecture? Alpha hemolytic. It is incomplete hemolysis. Beta hemolytic. This is complete hemolysis or hemolytic. And gamma hemolytic. That means nothing is happening. And today we hope to see, after you put the bacteria there is some difference. Okay, what do we do today's lab? Today's lab is very simple. Every single agar, you have 4 agar. Okay, everybody got 4 plates. You turn to the back. Split them onto 4 cords. We will do a spotting inoculation. We call it a spot inoculation. Which means you put a loop to touch the bacteria, you just do a very tiny streak there. What are the bacteria we're going to add? You have to label EC is E. coli. LF, so-called lactobacillus, but maybe Staphylococcus aureus. We'll see. Okay, remember we did it before gram stain turned up with Staphylococcus aureus? We'll see. What else do we have? Citric bacter, so we put CF. Another one is Bacillus bias. Don't forget, some age, label your bench number, your initial. And you can put the date there. 26. Okay, now how you do it? Everybody grab 4 agar. Neutral agar, blood agar, mannitol salt agar, and the McConkey agar. These 3 plates looks like similar. What you do, turn to the edge. This is very red. Plus labeled at the back because I buy it from a company. And this is we made it. When you turn to the edge, this is a little bit pink and this is very purple. Okay, and this is very red. So blood agar, mannitol salt agar, and McConkey agar. And this is, is a neutral agar. Okay? When you have these ready, do not forget, there is a condensation inside. Make sure you use a paper towel to clean, and the paper towel clean the back. Then you started to label the back, put on the 4 cords, write your name there, write your bacteria initial there, and then you started to do spot inoculation, use a loop. Where are you going to inoculate? Coming from the slants. EC is E. coli, Bacillus is BS, LF lactobacillus fermentum, and the citric bacter. Okay, and I can tell you one thing, E. coli is gram-negative. So-called lactobacillus is gram-positive. Bacillus subtilis is gram-positive. Citric bacter is gram-negative. After doing this, you use loop to inoculate. Let's say E. coli you already did it. Flaming. Okay, then you pick Bacillus, streak. Then you flaming. You pick Lactobacillus, streak. Then you flaming. And finally do citric bacter. And do this same for these 4 different agar. Which means neutral agar, Macanthi agar, mannitol salt agar, and blood agar for these 4. Don't cause cross-contamination. That is important because we could see the results on Thursday. Which one is growing, which one is not growing, why it is grow, why it didn't grow. There's a big story behind it, and we can talk about that. Okay, but just be careful. I just want to let you know that lactobacillus maybe it's Staphylococcus aureus. I'll tell you, I know it, if it's Staphylococcus aureus or not. Okay, very good. Then go ahead to do it.